All right, here we have a third identity to establish, and I would definitely say that the left side of this equation is more complex than the right side. So I'm gonna take cosine of theta over 1 plus sine of theta added with 1 plus sine of theta over cosine of theta, and I'm gonna try to prove that that eventually equals 2 times secant of theta. And once again, I've given a hint here. Notice I'm saying to write as a single quotient, which basically means take the two fractions that are being added together and actually combine them into one fraction, okay? That's going to require a common denominator. So I'm going to take the first fraction and I'm going to multiply it by cosine over cosine, okay? Then I'm going to take the second fraction and I'm going to multiply it by 1 plus sine over 1 plus sine. All right. And cosine times cosine, of course, is cosine squared. And then down below, I'm just going to leave this in a factored form. So let's just say cosine of theta times 1 plus sine of theta. All right. And then 1 plus sine of theta times 1 plus sine of theta, that's going to give me 1 plus 2 sine theta plus sine squared of theta all over that common denominator, cosine of theta times 1 plus sine of theta. Okay. Now I'm able to combine the two fractions together into a single fraction, which right now there are no like terms, so I'll simply just copy everything from the numerators all in a single numerator over that common denominator. Okay. And hopefully you're noticing that another Pythagorean identity can be used here. Cosine squared of theta plus sine squared of theta can simplify to 1. So this ends up being 1 plus 1 plus 2 sine all over cosine of theta times 1 plus sine of theta. All right, so if you didn't catch that, I took cosine squared plus sine squared, and I know that those equal 1. Okay. Now I combine my constants of 1 and 1 to give me 2. 2 plus 2 sine theta over cosine of theta times 1 plus sine of theta. And I can now factor a 2 out from the numerator. Once I pull that 2 out, notice I can reduce away 1 plus sine and 1 plus sine. That leaves me with 2 over cosine. And 2 over cosine is the same as 2 times the secant of theta using a reciprocal identity. And that's what I was trying to verify. Okay. All right, one final example. All right, let's establish that secant of theta minus cosine of theta divided by secant of theta plus cosine of theta is equal to sine squared over 1 plus cosine squared. I'm going to start with the left side of this equation and try to write everything in terms of the cosine function. Okay, so sometimes it's helpful if you rewrite everything in terms of just one trig function and then manipulate from there. All right, so starting here, secant of theta is the same as 1 over cosine of theta. All right. And then we can take this numerator and we could try to combine it into a single fraction. And then the same thing with this denominator. All right. Now there's a couple different ways you can do this, but basically you need a common denominator between what you're combining together, right? So I'm going to leave this as 1 over cosine and then make this cosine squared theta over cosine squared theta all over 1 over cosine theta plus cosine squared theta. Actually, I'm sorry, this I have a copying error, that should be minus. All right, and then back down here, cosine of theta. Okay, so then that gives me 1 minus cosine squared theta over the common denominator of cosine theta all over 1 plus cosine squared theta over the common denominator of the cosine of theta. All right, and we can either take this complex fraction and simplify it by multiplying by a reciprocal, or you can multiply by cosine over cosine. I'll get these to wipe out as well as these. That leaves you with 1 minus cosine squared of theta over 1 plus cosine squared of theta. And isn't 1 minus cosine squared of theta the same as sine squared of theta by the Pythagorean identity? Notice where we end up with sine squared theta over 1 plus cosine squared of theta, what I was trying to verify.